This question asks, the kinetic theory of gases assumes all of the following except, and so that means that 3 of these 4 statements are true. Excuse me. And so gas particles do not attract or repel each other. So that statement is true. That is an assumption of the kinetic theory of gases. And that's related to the fact, if we draw our picture of a gas, that there's so much space between the gas particles, and that space we said is approximately 10 diameters. And the fact that they do not attract or repel each other is because they are so far apart. And it's also aided by the fact that they're moving so quickly. And so if they do collide, all right, there we go. So, and here's my demonstration for today. So here is a collision between 2 gas particles. So first off, they're very far away, about 10 diameters. And then when they do collide, did you see that? They're close for such a short amount of time that any attractions are negligible or almost zero. And the kinetic theory of gases assumes that they are zero, that there are no attractions or repulsions. So 2 things make this statement true. 1, they're so far apart, and 2, they're moving so quickly that when they do collide. Now, if you look at a liquid, not only are they moving slowly, but they're always close together. And so in liquids and solids, attractions between particles are very important. All right. The sizes of gas particles are negligible compared to the size of the container. This is also true. And that just means that there's so much space in here that the actual amount of particles, or the volume of particles would be another way of putting it, is almost zero. And so I think in the lecture outlines, I talk about how the volume of particles, if you put all of the particles right next to each other, would be approximately 0.01% of the total volume, which means that 99.99% of the volume is open space. And watch as I move this pen through the gas phase because it's 99.99% open space. It moves as if there's nothing there, which more or less there is nothing there. All right, when gas particles collide, kinetic energy is lost. That is the one that is false. And we know that kinetic energy, and what we said was really average kinetic energy, is proportional to temperature. As long as the temperature is constant, which temperature doesn't change unless we say it does, then kinetic energy is not lost. It can be transferred between particles. If we have one of those particles in that distribution that's moving faster and one that's moving slower, and if they collide, then they can change the amount of kinetic energy that each of the particles has, but overall, kinetic energy is not lost. And gases are composed of particles in random ceaseless motion. That is also true. That is the one that is not true. Any questions about that?